Well, ladies and gentlemen, today we're going to learn about kinematic graphs. Now, because it's about kinematic graphs, I'm going to make this entire video while walking. All right, so in this course, you're going to come across a lot of different kinds of graphs, and it's very important to know what those shapes mean and what those shapes can tell you. For example, this one here, this is a linear curve, and because it's a linear curve, it tells you something special. So let's take a look at it. We know that it is a constant positive velocity. By the way, all of these graphs will be positioned over time. Okay? And because it's a constant positive velocity, there's no acceleration. We know this because it's a linear shape, which means that it's not speeding up nor slowing down. All right, here we have a similar graph. We have a linear line that is going in the negative direction, which means that it's a constant negative velocity, and it is straight, it's linear. Therefore, there is no acceleration. All right, next up, we have a funny looking one. Now, remember, this is still position versus time. However, this is not linear. Now, because it's not linear, what this tells us is that it's accelerating. Okay, so this is going up in the positive direction. Now, because it's going up in the positive direction, and we look at the slope, and we notice something about the slope. If we look at the slope, we see the slope is getting steeper and steeper. That must mean it's speeding up. Now, if we have positive velocity and it's speeding up, the only reason why is because there's a positive change in the velocity, and we call that the acceleration. So, a couple of key points. If there's a positive velocity with a positive acceleration, it is speeding up. Now, you'll notice that on the screen, I put in little positive symbols. If we have two of the same symbols, that must mean that the object is speeding up. Let's take a look at another one. Here we have something with a positive velocity, but notice what's happening to it. That steep slope is getting less and less steep, which means that it's slowing down. Remember, slope represents the velocity. So if the steep slope gets less steep, it's going from a fast velocity to a slow velocity or a slow speed, which means it's slowing down. Now here's a good indicator. The velocity is positive. However, the acceleration is negative. Therefore, it is slowing down because the two symbols are opposite of each other. All right, here's another one. Here we have an object, and it looks like the slope is very steep, and it's, ooh, what's this? Is this a negative velocity? I think it is. Now, because that's negative velocity, it's pretty steep for a negative velocity object. And then all of a sudden, that steep slope kind of smooths out. Now, what that means is that it's getting fast to slow. Now, because it's going from fast to slow, that must mean it's slowing down. Here's another indicator. The two signs are opposite of each other. So you go from a very steep slope to a not so steep slope, slowing down. All right, here's another one. Here we have an object with a negative velocity, but then that negative velocity, that slope, is getting steeper. Now, because it's getting steeper, that must mean that it's speeding up. The speed is increasing. Uh-oh, I made a mistake there. That should be a minus sign. All right, here's another one. Oh my gosh, brand new. This is a parabola or a U shape. Now, if you ever see this, this is a double kind of thing, right? So what you want to do is you want to break it down into two parts. You want to break it down at the point where the velocity is zero, and I indicated that. Now, how do we know velocity is zero? You might be wondering. Well, at that point, there is no slope. If there is no slope, there is no speed. If there is no speed, there's no velocity. Okay, so we're going to go from left to right up until where the velocity is zero. So there is a negative velocity with a positive acceleration. How do we know that? Well, it has a very steep negative slope, but then it kind of smooths out. That must mean this object is slowing down. But remember, this object is experiencing that positive acceleration still. Now, it used to have a negative velocity, but that negative velocity turned to zero. Now, because it turned to zero, that negative acceleration is going to start to speed, or the positive acceleration is going to start to speed it up, so that it has a positive velocity. And when it has a positive velocity with a positive acceleration, we can declare that as a speeding up object. All right, here's a different one. Once again, we need to pinpoint when the velocity is zero, and it's at that peak right there. At that point, your velocity is 0 meters per second. Your speed is 0. So let's go from left to that 0 meters per second mark. We can see that there is a positive slope going up now because there's a positive velocity, but we see that slope kind of flatten out. Okay, it goes from a velocity to 0 velocity. That must mean it's slowing down. The only way that it can slow down is if it has a negative acceleration. Now, after the 0 point, it still has that negative acceleration that we see. So it goes from 0 meters per second to a negative velocity thanks to the negative acceleration. Okay, negative velocity, negative acceleration. It must mean that it's speeding up. All right, now here's a couple of new tricks that we're gonna learn when we are observing graphs. Here's a velocity versus time graph. We'll be able to make these pretty soon. Now, when we are observing velocity versus time graphs, there's a very nifty trick that we can do. Now, we know that the velocity is equal to displacement over time. So I see two of those variables here. I see velocity and I see time. Now you might be scratching your chins and wondering, where is displacement? Well, if you follow these steps, you can find it. First, you need to take a look at the units for the y-axis, which is meters per second. Then you need to take a look at the units for the x-axis, which is seconds. Okay. Now, watch this. When you multiply the two axes together, meters per second times seconds, because we have seconds in the numerator and the denominator, they disappear or they turn into 1. So our leftover units is meters, which coincidentally is the same unit as position, aka the distance or the displacement, depending on what you're looking at. So that's what we call the area under the curve. When you multiply the y with the x, the base times height. Hint, hint, wink, wink. All right, so if we do the base times height for the red area here, okay, for that red line, we get a rectangle. So all you have to do is find the area for that rectangle, and you will find the total displacement. Ooh, all right, now let's take a look at the green line. So the green line is a little bit trickier because there's a positive region and a negative region. So here's what you do. You look at the positive region until it reaches 0. That is a triangle. Very good. Now, because it's a triangle, triangles have a special equation. Now, you can do normal base times height, but you have to multiply that by 1/2. So 1/2 base times height is the equation for a triangle. If you do that, you get that tiny little sliver, but that's not the entire trip now, is it? So what we have to do is you have to find the area of the curve from the curve, which is the same thing as a line, to the 0 line. And if you do that, you get a separate triangle, and it looks like this. Okay. Now be careful. A lot of students want to find the shape which is on the opposite side of it, but don't do that. It's from the line to the 0. Okay. Now we do the same thing for the blue region. We get the negative area, and we add it to the positive blue, and whatever the sum is the total displacement. All right. One last thing that we're going to be looking at is the instantaneous slope. Now, in this case, the instantaneous slope will be, well, let's take a look at it, position versus time. The slope is velocity. So in this case, it'll give us the instantaneous velocity. So what you're going to do is you're going to draw a tangent line, which is just a fancy word for a line that touches exactly 1 point. You're going to find the slope of that line, and that, ladies and gentlemen, gives you the instantaneous velocity. Remember, always use rise over run. y2 minus y1. Any point that lies on that line you can use. I suggest that you choose a point that lies on the crosshair, such as, if we take a look at the cursor, right around there is right around the crosshair, and right around there is around the crosshair, okay? I would use those two for y2 minus y1 over x2 minus x1, which is the mathematical formula for rise over run.